Uy, tara, sabay tayo kumain. Sabay tayo kumain. Gusto mo, buti na lang.
In this scenario, we have two parts to our network, each one with its own path to our ISP and the Internet. Packets originating from PC1 are eventually forwarded to router A and on to the ISP, while packets originating from PC2 are eventually forwarded to router B and then on to the same ISP. But what happens when there is a problem with router A or with a link used along the path to router A? Packets requiring router A to forward them onto the Internet will get dropped and can no longer reach their final destination. A fault-tolerant network is one that can continue operations without interruption when one or more components of the network fail. We have now installed additional links in our network, giving us multiple paths to reach our ISP and the Internet. Having multiple paths to a destination is known as redundancy, one of the ways to help make the network fault-tolerant. If one path fails, the packets are automatically forwarded using a different link. The more redundancy in a network, the more fault-tolerant the network becomes.
In this video, we're going to look at how we get information about the various network interface cards that are contained in our PCs. In the case of this laptop, I have both a wired and a wireless NIC. In order to view the properties of these devices, I need to go to the Network and Sharing Center. I can do this easily by going to the System Tray icon, right-clicking, and opening the Network and Sharing Center. This brings up the list of connections that I currently have active. As you can see, this is my computer, and I have multiple networks that are connecting to the internet. To look at the individual adapters, I need to go to the Change Adapter Settings. As you can see, I have a local area connection, which is a wired connection. You may be able to see the wire coming out of the back of my laptop. And I also have a wireless network connection. To view the properties of a particular connection, all you have to do is right-click and go down to the properties. There are a number of different properties that are associated with a network adapter on a Windows PC. Usually what we're most interested in are the settings for the Internet Protocol. In this case, we're going to view the properties for the IPv4. If we go in here, we can see that our device is receiving its IP address automatically. That means it's being given out by a DHCP server and was not configured statically. If I then go out to look at my wired network adapter, do the same exact thing and go to the properties and choose IPv4, you can see that on this adapter, my IP address was statically configured. That means an administrator assigned the IP address to my PC specifically, and it was typed in manually. More information can be gained by looking at the status information of this particular connection. I can see very briefly that I can get to the internet and that my device has a very good signal coming from the wireless access point. If I go into the details, I can even get more information. You can see here the different type of connection that I am going to, where I'm getting my DNS. And my DHCP configuration for this particular adapter will expire on Wednesday, December the 14th, and I'll have to renew it from the DHCP server. You can get the information about the MAC address, about the type of connection, and the wireless networks on which you're connected. In the local area connection, the information that you get is slightly different. It tells you right now that in the case of my wired network, I am not getting out beyond the first hop of my network, and that my connection itself is enabled and it is at 100 meg. Again, we have the details where I can get my MAC address, and I can also see my IPv4 address, and if I had an IPv6 address configured, it would also be displayed. Now, most of this information that you see in the NIC driver information status can be also viewed by going to the command prompt within Windows and doing an IP config. IP config has a number of options. The most commonly used one is the /all, which gives you much more information about how your device is configured. As you can see here, here is my adapters that I have for wireless and also for the wired connections. It is a very common practice that you have to find the MAC address, the IP address, and the current status of a PC adapter. So this is a skill you will get a lot of practice using. In this video, we're going to talk about the benefits of a hierarchical design when planning a network. Usually networks grow kind of organically. We start out with a small device and a few workstations. Think about your home network. You have a couple of computers and you have some other devices, perhaps a printer, and perhaps maybe a game console. And all of these things plug in or connect wirelessly to your home network. But imagine that if you began a home-based business. All right? Your network would then need to grow. You might need some additional devices, some additional workstations. You might need some additional things like scanners and printers. So I might have a scanner out here and maybe another printer. And then all of a sudden I realized that my small little home networking device no longer has enough ports to support all of my various devices. As my small business grows and we remodel the garage to put it in, now I have to have another device. And usually we attach that device to the other device, and then the network begins to grow organically. This is true of your home network, but it's also true of enterprise networks. Many times businesses of all different sizes don't think about how they're creating their network. They just allow it to grow as they need more devices on the network. But pretty soon, we end up with a network that has mission-critical devices, say, for example, a server that your customers needed to get to, attached with things that really don't need to see that types of traffic or might actually even interfere with it in the case of the game console or someone, downloading a movie. So basically, a network that just grows organically is sometimes not all that efficient. So what we see is, over time, a different type of network architecture has become pretty much the standard, and that is called a hierarchical network design. In a hierarchical design, we think about how are we going to organize our network such that we have important things like servers separated from the user groups that might be, again, those people downloading Netflix or playing a video game. And we want them separated from the users that have to be critically important. Now, you also will see in enterprises and small businesses, this process is repeated multiple times. And hierarchical networks are able to scale because they are logically designed in a manner such that traffic that needs to go from these people to these servers does not need to travel over to the areas of the network where it's not necessary. Now, we had a little discussion earlier about broadcasting. Broadcast packets go to everyone that is in the same local network, meaning the same area of the network that is only connected by a switch. So in this instance, all of the broadcast traffic that is generated by the various devices, and even though I've only drawn a couple, in some cases this could be hundreds of devices. So all of the traffic that's generated by these devices will remain in this area of the network. So hierarchical networks scale quite well. Now, when the hierarchical network needs to connect to other networks, we will have other devices that provide the connectivity to get out to, say, the internet. In a hierarchical network design, there are names given to these various layers. Devices that actually connect to users and other end-user devices reside at the access layer. The primary function of the access layer of the network is to provide an entrance point for devices to get on the network. Types of things that are at the access layer are end user computers, but you'll also see IP phones and access points that provide wireless entry. And at some degree, you will see servers and services being provided at the access layer. The next layer up is the distribution layer. The distribution layer and traffic that needs to traverse to remote networks actually has a path to use to get from one network to the other. Now, above all of that is the core layer. The core layer is responsible for the high-speed processing. So in this case, we have all of our users part of our networks before we're building them. It's not really critically important when you're building a home network, but once you start into a network that needs to be up and operational most of the time, you really have to think about having a design that a failure of this component does not impact all the rest of the network.